My name is Illian. I'm senior lecturer at the University of Sussex, lecturer in astronomy. So basically every simulation is you create your own universe and you essentially know everything about your own universe. My main interests are basically simulating the universe at large scales and especially at very early stages of the evolution of the universe, and how the first stars and galaxies formed and how they affected their surroundings and how the universe evolved over the first billion years or so.
When we run a simulation, what we do is we take the picture that we've got of the very early universe from the cosmic microwave background radiation. This radiation gives us an idea of statistically how the universe looked in its very early form. So what we do is we use this high and low density description of the early universe to put all of our particles in this box. Okay, so we've got a volume which we're simulating. Typically they're always cubical volumes. We put the particles in. All the particles are is, for the computer, they're just 6 numbers. Where the particle is in terms of its position and what the particle's velocity is. For the velocity, you need to describe its velocity in the 3 different directions of the simulation. We put them in their initial positions based on what the cosmic microwave background tells us. And then all we do is very simple. All we do then is evolve the particles using the force of gravity. So the ingredients you have is you've got your initial conditions from the cosmic microwave background, and then you've got Newton's gravity, and using only those 2 things and a very large supercomputer, we can actually create the structures that we see in the worlds, in the universe today.
The universe, after the famous Big Bang, it starts expanding very quickly first. As it's expanding, it's cooling down basically, just like air. When you blow, it cools down and gets colder over time. So the universe becomes from very hot and completely ionized, becomes cool and dark and really boring place. Eventually, gravity takes over. The first small fluctuations start growing. So they eventually form the first stars and the first galaxies. They start emitting photons and they start ionizing the gas around them, kicking electrons out of the atoms. And this process eventually completes and the full universe becomes ionized. And that's what we are trying to study, how this happened, what were the consequences on galaxies, on stars. Sussex is part of LOFAR. It's a big collaboration including universities and institutions all over Europe. This is flying through the image cube of LOFAR telescope. So what we are seeing is basically as we go from high to lower frequency and towards the present. The blue holes are ionized regions where the neutral hydrogen has disappeared, and the rest is the neutral. And essentially what happens is that all the neutral hydrogen disappears as you ionize the whole universe, and it becomes all red, so ionized.
So the simulations I've been doing have been trying to model volumes which are comparable to the entire universe itself, but also with enough detail that we can actually see what's going to be happening in those volumes in terms of the structure that's being formed in the universe. An important thing in simulations is, do they work? Are these things actually viable scientifically? And the way we ask that question and answer it is by comparing what we see in the simulations to what we see in the sky.
So yes, certainly you are basically a ruler of your own universe and you know everything about it, but it's a very simplified version of a universe and possibly not the same one we actually live in. So you have to be a bit careful with that.
We're in this unfortunate position on the Earth where we've only got one observational point. We don't know whether our observational point is perhaps slightly different from, say, a normal observational point in the universe. We assume that it's the same as any other point in the universe, just in terms of looking out and asking ourselves where the galaxies are. So in the simulation, we're in this privileged position where we can put ourselves anywhere in the simulation and look out and see what the distribution of the galaxies in the simulation would be.
If the simulation is good enough, you wouldn't be able to tell if you live in it, I don't think.